Welcome back to the new video. Today we will take a look at section 2.3 with the topics of properties of divisibility. And these are properties of divisibility that you need to know to prove theorem involving divisibility. Now, let's take a look at theorem 2.3.1. We let a, b, and c be integers, and we have the following properties of divisibilities. Now the first one, a divide 0, 1 divide a, and a divide a. So the first one is very easy because we know that all the numbers divide 0. And number 1 can divide any number. And any number divide itself. Okay? That's the first property. The second property, a divide 1 if and only if the divisor is 1 or minus 1. That's the second property. The third property is if a divide b and b divide c, then a divide c. So division has transitivity properties or transitive properties. So we have transitive properties under division. The fourth one is if a divide b and c divide d, then ac divide bd. Okay? Number 5, if a divide the sum of two numbers, let's say a plus b, and a divide one of those numbers, a must divide another numbers. That's the fifth one. So if you have the sum of two numbers that is divisible by if you have the sum of two numbers and one of these numbers is divisible by a number, another number must be divided by the same number. Okay. Number 6, a divide b and b divide a if and only if a equal minus or plus b. Okay. And number 7, if a divide b and b is not 0, then divisor must be less than or equal to dividend. Okay, or we can say that the absolute of divisor must be less than or equal to the absolute value of the dividend. And number 8, if a divide b and a divide c, then a divide bx plus cy for every integer x and y. Okay, so now let's take a look at the proof of all of these properties. So I want to start with the first one. So the first one, we have to prove that a divide 0 and 1 divide a and a divide a. So we have to let a be, so let a be integers. Give me a second. Let a be integers. Okay, then what do we have? So we start from 0. As we can see, you can write 0 times a, right? Okay, you can write 0 times a if you consider 0 and a. Okay, so by divisibility. Okay, so the by divisibility, a divide 0. Okay, a divide 0. Do not forget that if you have a divide b, you will have q, which is an integer, such that b equal a cube. Okay, now let's go to here, 1 times a. Okay, Now, what is 1 times a? I want to start with a. So we gotta have a times 1, right? We can have a times 1. So from this equation, we gotta have, so by divisibility, we gotta have 1 divide a. Okay? So 1 divide a. Alright? Another one, if you have a, so a can be written as 1 times a. So by divisibility, what do we have? So we're gonna have that a divide a, right? Okay, so a divide a. Okay, so we use this divisibility. A divide b if and only if you have quotient q, which is an integer, such that b equal to a times q, or you may write q times a. Okay, so this is what we have for the first property. Now let's go to the second property. A divide 1 if and only if a equal 1 or minus 1. So take a look at this property and let's prove it. So we will let a to be an integer. Okay, so if and only if I want to start with from the left to the right. So we assume the left and show the right, right? So we have to assume that a divide 1. Okay, when a divide 1, what do we have? Okay, when a divide 1 by divisibility, there exists q, which is an integer, such that 1 equal a q, right? Okay, such that 1 equal a q. Okay, so what can we do with this? 1 equal a q. Okay, so what is that q and what is that a, so that is satisfying this equation? Okay, but these two numbers must be integers. So we're gonna have, so a must be 1, q must be 1, right? Okay, so that, okay, so that 1 equal to 1 times 1. Okay, so that's what we have right here. So what about another a and q? Okay, what about another k, a and q? If you want to have a equals 2 minus 1, so what do we have? So we can have 1 equal to minus 1 times minus 1, right? Okay, so this means that a equal to minus 1, q equal to minus 1. So I think I have to write this one to be a better version. So we can write 1 equal to 1 times 1. Okay, so this means that our divisor, which is a, can be 1 and divided must be 1. So we've just shown that a can be plus or minus 1. Okay, now let's prove from the right to the left. So we have to assume that a equal to plus or minus 1. So what can we do with this? We want to show that a divide 1. So we have to start with number 1, right? Okay, number 1. So we know that number 1 can be written as 1 times 1. Okay, it can be written as 1 times 1. So what can we do with this? We have to show that a divide 1. So we gotta have 1 divide, okay, 1 divide 1, right? Okay, and a is 1, so we gotta have a divide 1. Okay, and number 1 here. Number 1 can be written as minus 1 times minus 1. And a is minus 1, right? Okay, and a is minus 1, so we gotta have minus 1 times a. So that means that a divide 1. Okay, it's like we split into 2 cases, a equal to 1 and a equal to minus 1. Okay, for the first case, we gotta have this one. Okay, so if I write this one, so we gotta have 1 equal 1 times 1, which is a. Okay, so that means that a divide 1. Okay, that's number 2. Now let's go to the third one here. Transitivity under divisibility. So what can we do with this? Okay, what can we do with this? Now let's go to here. Let me use the green one. Okay, right here. So the third properties. What can we do with the third properties? So we have to let a, b, and c be an integer. Okay, and then I have to assume that a divide b and b divide c. So by divisibility, what do we have? So they exist. Let's use R and S such that, so a divided b, we gotta have b equal to AR. Okay, and C equal to BS. All right, C equal to BS. Okay, I want to have A divide C, so I have to write C. So what happened to C? As you can see, we gotta have C equal to BS, and B is AR, right? A times R, S like this. So we gotta have A times SR, and SR is an integer. So this implies that A divide C. So we have proved the third properties. Okay, now let's go to the fifth properties. The fifth properties, if A divide B and C divide D, then AC divide BD. Okay, so let's try to prove this property. So we have to let, okay, we have D right here, right? Okay, we have D. Where does D come from? Okay. Okay, so I have to write D right here to be an integer too. Okay, sorry for my typo. So we let A, B, C, and D be integers. And then we have to assume that A divide B and C divide D. Again, by divisibility, we gotta have R and S, integers R and S, such that b equal to AR and D equal to CS. Okay, then what do we have? We want to show that AC divide BD. So let me write BD. Our B is AR, D is CS. So we substitute into here AR times CS. Then what can we do next? What we have to do is to try to have AC. Okay, so we're gonna have, we're gonna have AC times RS. Okay, AC times RS. So what do we have? RS is an integer, right? So since RS is an integer, we can imply that AC divide BD. That's the fourth property. Okay. So now let's go to the fifth properties. If A divide B plus C and A divide B, then A divide C. So what do we have here? Take a look at the fifth property. The fifth property is here. Okay. That's the fifth property. So we let A, B, C be an integer. Okay. And then I can assume that A divide B plus C and A divide B, and try to show that A divide C. Again, we're gonna use divisibility. So their axis, let's use R and S, which are integer, such that B plus C equal to AR. And what about A divide B? We can have integer S such that B equal to AS. And we want to show that A divide C. Okay, so how come can we have C here? How do we have C? So we start with letter C, which is an integer. As we can see, C is going to be AR minus B, right? C is AR minus B, and B is AS. So we gotta have AR minus AS. And then we factorize A, we gotta have R minus S. And R minus S are integer, right? Okay. And R minus S is also an integer. So now our C becomes A times RS, and RS is an integer. So we have proved that. So we have proved that A divide C. Okay. So A divide C. That's what we have. Now let's go to the sixth property. A divide B and B divide A. If and only if A equal to B equal to B or minus B. So let's start with assume this one and prove that A equal to B or minus B. So we start with from the left to the right. So we have to assume that A divide B and B divide A. Okay. So what do we have? So there exists R and S. Okay, which are integer, such that B equal to AR and A equal to, okay, B equal to A, so we're gonna have BS. Okay, BS, right? So try to show that A equal to B or plus B. So try to write I want to start with B. So our B, which is AR, and A is BS, right? Is BS times R. Okay, so right now we gotta have, so now we gotta have, it's like B equal to BSR. Now since B and SR are integer, what happened? Okay, what happened? That means that SR must be 1, right? To preserve this equation, SR must be 1. Okay, now we have SR, which is 1, so we have the product of two numbers, which is 1. So what do we have right here? Since SR equals 1, so there will be just two cases. The first case is R is 1 and S is 1, or both R and S are minus 1. Okay, R and S are both minus 1, and there will be two cases. So when R and S is 1, what happened? So let's start with this case. No, I think we start with if. Okay, if R equals 1 and S equals 1, then what do we have? How to show that A equal to plus or minus B? So we want to start with this A. Okay, we start with this A. So what happened? We gotta have A equal to BS, and what happened to this one? A equal to B times 1, which is B, right? Okay, and B equal to AR. What happened when R is 1? What do we have? We gotta have A times R, so B equal to A. So from this case, if R and S is 1, A equal B. Now, if R and S are both minus 1, what happened? Okay, if R and S are both minus 1, what happened? So we start from A equal BS and S is minus 1, right? Which is minus B, and B, which is AR, and R is minus 1. So B becomes minus A. Okay, so B becomes minus A, so we have A equal minus B and B equal minus A. So we might imply that A equal minus B. Okay, hence, what do we have right here? We could have that A equal plus or minus B. Okay, now let's assume that A equal to plus or minus B, and try to show that A divide B and B divide A. I think this one is quite obvious. So we have to assume that A equal plus or minus B. Okay, so then there will be two cases, right? A equal B or A equal minus B. Okay, so let's start with the first case, the case where A equal B. So when A equal B, what happened? Okay, when A equal B, that means that A equal, so when A equal B, we might write 1 times B, right? So B is a factor of A. Okay, that means that B divide A. Okay, or you might have from A equal to B, you can have B equal to A. That means that you may have B equal to 1 times A. So we gotta have A divide B. Okay, in the first case. Now another case, the case where A equal minus B. So we may write A equal minus 1 times B. So we're gonna have B divide A. Okay, and A equal minus B, you may have minus B equal A. Okay, minus B equal A or B equal minus A. So what is minus A? Minus A is minus 1 times A. So that means that, so from this one we gotta have A divide B. Okay, this one is quite obvious. So we're gonna have A divide B and B divide A. Okay, that's the 6th property. Let's go to the 7th property here. What is the 7th property? For the 7th property, if A divide B and B is not 0, then A is less, absolute of A is less than or equal to absolute value of B. So we let A and B be integer and B is not 0. Let's assume that A divide B. Okay, what happened when A divide B? So there exists an integer R such that B equal to AR. Okay, B equal to AR. So A divide B, right, in this equation. And then what do we have here? Okay, let's write absolute value. So absolute B equal to absolute of AR, which is absolute A times absolute R. But what is R exactly? R is the divisor, right? Okay, sorry, A is the divisor, R is the dividend in this case. So if we take absolute value of R must be greater than 1. Okay, so since absolute value of R is, give me a second. Absolute value of R is greater than or equal to 1, and absolute value of B, okay, let me write like this, and we have absolute of R, absolute of A times absolute of R equal to absolute of B. Okay, then what do we have? AR, what happened to AR? Absolute value of AR, let me write like this. Let me write absolute of B equal to absolute of A times absolute of R greater than or equal to absolute of A times 1, which is absolute of A. As we can see, we gotta have absolute of B greater than or equal to absolute values of A. Okay, so we have absolute value of A less than absolute value of B. Okay, that's the 7th property. Now, let's go to the 8th property. Okay, let's go to the 8th property here. So what can we do? Let's go to the 8th property. So what can we do with this? So we gotta let A, B, and C, okay, and X, Y be integer, okay, and then assume that A divide B and A divide C. And we try to show that A divide bx plus cy, where x and y are any integers. Okay, so let's try to write this. So what do we have right here? So their x's. Let's use r and s, which are integer, such that b equal to ar, okay, ar or ra. Let's use ar, okay. And what happened to c? C equal to as, okay. Now let's write bx and cy. So what do we have here? B, which is, I forget to write bx. Bx becomes arx, right? And what happened to cy? It becomes c times, okay, what is y? Oh, c is as, okay? Asy. Alright? So what do we have right here? We're gonna have bx plus ay, and bx is arx. What is ay? It's cy, actually. Cy, not ay, sorry. It's cy. And cy is asy. And we can factorize a, so we're gonna have rx plus sy. Okay? And rx plus sy is an integer. Okay? And rx plus sy is an integer. So we have shown that bx plus cy has a as a factor. That means that a divide bx plus cy. Okay? So a divide bx plus cy. Okay? That's what we have. Right? Okay? This is property that we have to know. These are the 8 properties. Okay? So, that's it for this video.